what is the purpose of the formal charge? So now purpose, and organic compounds are composed mostly of carbon and hydrogen. Okay, but also may have other elements and atoms. And formal charges work very well for organic compounds when they're drawing the best Lewis structure. How do these satisfy the octet rule in organic compounds so as to have a formal charge of 0? So with this being said, actually we're just going to refer to the answer here because they do a pretty good explanation of it. I'm just going to highlight key points here, okay? Formal charge is a charge of an individual atom within a molecule or in a compound based on the electrons that it's holding or it's sharing, okay? So that being said, okay, everything has its own like formal charge. Let's say we're dealing with NH3, okay? This nitrogen's formal charge will be based on the electrons that it has by itself right here, and the electrons it's sharing, which are these 3, okay? Now in order to actually calculate that, what we do, as they show this formula here, is the number of valence electrons. So nitrogen is known as, nitrogen has 5 valence electrons, and then we put a parenthesis here, and then it says number of non-bonding electrons. I like to think of it as just lone pairs times 2, but non-bonding electrons, you just count exactly how many electrons aren't bonding anything, and so that would be that N. I have it here plus because I put it in the brackets. It's going to be number of electrons shared in the bond, but divided by 2. Because if you're sharing them, you're really technically having one. You don't know which one you're having, but you're kind of having one of those 2. Hence how you're sharing. So with that being said, the formal charge of nitrogen in this ammonia, if you just plug in the numbers, it typically has 5 valence electrons based on the periodic table. It has only one by itself that is not bonded to anything, so that's 2, well, 1 lone pair, so that's 2 electrons. And then here it's actually sharing in total, if you counted each bond is 2 electrons, 6 electrons is sharing divided by 2. So you have here that the formal charge of nitrogen is indeed 0, okay? So that's perfect. That's just an example of what it does. If you're dealing with now NH4 plus, okay, so this is ammonium, okay, you would see here that if you plugged it in, we still have 5 classes valence electrons, but nitrogen no longer has any that it's that it has by itself, no lone pairs, and it's actually now sharing 8 electrons. So 8 divided by 2, that's 4. So we have a charge of plus 1. So you will see actually that on the nitrogen, the formal charge of why ammonia is NH4 plus, as you write it out, is because the plus is actually on the nitrogen in that molecule, and we can show this by how we did the formal charge. With this being said, the purpose of formal charges is that the reactivity and stability of the atoms are structured can be tracked. The key thing is that they always typically want to follow a formal charge that has the most neutral charges. If they can help it or rearrange themselves, they would want it to where they have as many zeros as possible in that molecule instead of having it like +2, -2 and such, because you'll still get a net charge of 0, but it just, if it's possible, preferably they would rearrange the bonds to where you have just a 0 and a 0. So exactly, and the last thing they address is the whole carbon, nitrogen, hydrogen, so 2 nitrogens, but carbon, nitrogen, hydrogen, and oxygen, and chlorine. They satisfy the octet rule by sharing electrons with other atoms. And the key thing is here is that they do specific ways of sharing. And you'll notice that some things, I guess, yeah, they want to talk about the satisfying the octet rule. So some things will, depend on how they're bonded, will ignore the octet rule in order to get their proper formal charge. But that typically doesn't happen with organic compounds. organic compounds are typically nice to where they can find a way to be able to bond with each other to be able to satisfy the octet rule and the formal charge. A perfect example of this would actually be like when you're dealing with acids. So if you had RC, this is just going to be like the carboxylic acid. Point being though is that the formal charge, if you actually solve for oxygen up here, in fact, it's 6 valence electrons, it has 4 by itself, and it's sharing 4 of them, and that's how you got 0. Okay, so with that being said, this one checks out. And in fact, if you saw that this oxygen got deprotonated, so you end up with like that, where there's a minus on the oxygen here, you would see here that it actually has a reason to be negative, because if you had 6, right now this oxygen has 6 electrons it holds by itself, and it has 1 bond, so 6 minus 7, that's how you got the minus 1. And you can see here that it actually shows as well that it's still following the octet rule. Everything is still good there, but the negative charge just had to go somewhere, and that is the best place you can keep it, because as you can see, carbon still follows the octet rule, this oxygen still follows the octet rule, and everything attached to the R and so forth follows the octet rule. So that's what it means. Like, there is ways to rearrange it to where you will satisfy the octet rule and make sure that there is only a formal charge when necessary. You're really trying to make it into a necessity rather than just making things, you know, plus minuses as many as possible. It's only like if there's nowhere else for it to go, we have to put it somewhere that would make everything else feel at ease. So with that being said, this is correct. Okay. So now we have, what is a Lewis structure of formic acid? So actually, rather than answer this question, we're going to tackle this in our next video. So we're actually going to stop here. I just want to thank you again for joining me this afternoon. Well, this morning actually. If you have any more questions, you want to tackle more of these and just really understand, please check out our tutors and links in the description below. We're more than willing to help you. But with that, you have a wonderful rest of your day. Thank you for joining me this session, and see you next time.